Greetings, curious minds. Welcome to Frontier Obscura, where we dive deep into the bizarre, unravel the unknown, and shine a light on the shadows of science. Buckle up for a journey to the edges of human knowledge. This episode is sure to please tech enthusiasts and animal lovers, as we dive into a world where nature's underdogs are leading a robotic revolution. Before we meet our animal stars, let's quickly break down what biomimetic robotics actually means. Simply put, it's the practice of designing robots that mimic biological systems. Engineers study how animals move, adapt, and solve problems, then apply these principles to create more efficient and versatile robots. It's like nature's greatest hits album, but for technology. The sticky gecko. First up, we have the gecko. Sure, you might have seen one scurrying across your wall, but did you know these little lizards are inspiring a whole new generation of climbing robots? Geckos can effortlessly scale vertical surfaces and even walk upside down on ceilings. Their secret? Millions of microscopic hairs on their toes that create a molecular attraction to surfaces. Scientists have replicated this with a material called Gexskin. Enter the GeckoBot. Researchers at Stanford University have developed tiny robots that can carry over 100 times their own weight while climbing walls. Imagine search and rescue robots scaling burning buildings or inspection bots checking the hulls of ships without the need for scaffolding. These gecko-inspired robots could revolutionize how we maintain and inspect large structures. The unassuming Earthworm. Next, let's dig into the world of the humble earthworm. These slimy soil dwellers might not seem like much, but they're inspiring a new wave of burrowing and tunneling robots. Earthworms move using a unique method called peristalsis, alternating waves of muscle contractions and relaxations. This allows them to navigate through tight spaces and varying soil densities. Scientists at MIT have created a soft worm-like robot called Melloworm that can squeeze through tight spaces and even repair pipes from the inside. These robots could be game changers in disaster zones, squeezing through rubble to locate survivors, or in agriculture, monitoring soil conditions without disturbing crops. Now let's shrink down even further and meet one of the toughest creatures on Earth, the tardigrade, also known as the water bear. These microscopic animals can survive extreme conditions, including the vacuum of space. While we're not building spacefaring micro-robots just yet, the water bear's resilience is inspiring a new class of durable robots. Researchers are developing materials and designs that mimic the tardigrade's ability to withstand extreme temperatures, pressures, and radiation. Imagine robots that could explore the harshest environments on Earth or even other planets, all thanks to lessons learned from a creature smaller than a grain of sand. Let's dive underwater and meet the Cuttlefish, a master of disguise that's inspiring a new generation of soft, shape-shifting robots. Cuttlefish can rapidly change their color and texture to blend in with their surroundings. They do this using special cells called chromatophores and by altering the shape of their skin. Engineers at Cornell University have developed a stretchy material that can change texture on command, much like cuttlefish skin. This technology could lead to robots that can adapt to their environment, squeezing through tight spaces or camouflaging themselves for stealth operations. Now let's shrink down again and enter the world of the leafcutter ant. These tiny insects are agricultural experts cultivating fungus gardens in their colonies. What's interesting about leafcutter ants is their ability to work together in large numbers to solve complex problems. This has inspired a whole field of swarm robotics. Researchers are developing small, simple robots that can work together in large numbers, inspired by leafcutter ant colonies. These swarm bots could be used for tasks like environmental monitoring, disaster response, or even microsurgery. Imagine a swarm of tiny robots entering the human body to deliver targeted medication or perform minimally invasive procedures. Let's head back underwater to meet the Brittle Star, a relative of the starfish with long, flexible arms that can move in any direction. What's unique about the Brittle Star is its decentralized nervous system. Each arm can act somewhat independently, allowing for complex movements without a centralized brain. This has inspired roboticists to create modular robots with distributed control systems. The Orobot, developed by the University of Oslo, is a snake-like robot inspired by brittle stars. It can change its shape to navigate complex environments and even reattach parts if they're broken off. This could be incredibly useful for search and rescue operations in unstable environments. Let's float up into the air with the Dandelion Seed. These light, fluffy seeds can travel vast distances on the slightest breeze. Engineers at the University of Washington have created tiny sensors inspired by dandelion seeds. These sensors are so light they can be carried by the wind, allowing for wide-scale environmental monitoring without the need for power-hungry drones. Imagine releasing a cloud of these microsensors to monitor air quality across a city or track weather patterns over a large area. It's a prime example of how even the most common plants can inspire cutting-edge technology. For our final stop, let's dive deep into the ocean to meet the Firefly Squid. These small cephalopods are masters of bioluminescence, producing their own light through chemical reactions. Scientists are working on creating artificial bioluminescence for robots. This could lead to robots that can illuminate their surroundings without the need for external power sources. Imagine deep-sea exploration robots that light up the ocean depths using principles learned from these tiny squid. As we've seen, the world of biomimetic robotics is full of surprises. From Gecko-inspired climbing bots to wind-borne dandelion sensors, nature's less famous creatures are providing solutions to some of our biggest technological challenges. But this is just the beginning. As we continue to study the natural world, who knows what other innovations we'll discover? Maybe the secret to more efficient solar panels lies with a desert beetle, or the key to better artificial intelligence could come from studying slime molds. The field of biomimetic robotics reminds us of the importance of biodiversity. Every species, no matter how small or seemingly insignificant, could hold the key to groundbreaking technological advancements. It's a powerful argument for conservation. We need to protect these species, not just for their intrinsic value, but for the lessons they can teach us. So the next time you see a gecko on your wall or blow on a dandelion, remember, you're looking at the inspiration for cutting-edge robotics. Nature has been solving complex problems for millions of years, and we're just beginning to tap into this incredible reservoir of knowledge. And if you like this episode, be sure to like, subscribe, and share this video with a friend.